Hello guys, Bartek here. In the last video I was talking about ChatGPT-generated code for controlling LEDs on the Raspberry Pi. Unfortunately, we find out that it had many architectural issues. The most critical one is that it was not following the solid principles. Okay, so let's fix it today. Let's change this spaghetti nightmare into architectural masterpiece. Okay, let's go. But first things first, let's think about the design of our application. Here is the basic model of it. So we've got the client, which will connect to the server via the gRPC connection, then the business logic, which will handle the message, and after that the hardware abstraction layer will control the physical LEDs. And on the other side I've got the class diagram, which we'll use in our application. So since the design is ready, let's implement this. I will get back to you in a minute. Okay, I'm ready, so let's dive into the implementation, but first let's check the original one. So here I've got my Visual Studio Code, I'm connected to my Raspberry Pi directly, and here we've got this old implementation, so everything is implemented in the same class. Everything resides in the setColor method, as well as the LED strip is initialized in the LED controller service. So let's now switch to the branch where I refactored everything. Okay, so as you can see, we are on the Refactor branch. So here we've got our Refactor application. Let's bring the class diagram that we'll have used here. So first let's go with the LED controller servicer. As you can see, it's dependent only on the gRPC imports. It's responsible for getting the message and pushing it to the handler, which is provided during the initialization of the LED server. The entire request will be pushed into the handle method. So let's go to our handler implementation. We've got the setColor class, which implements the handle method. So here we've got the taking out the color out of the message, deserializing it, so in our case is just casting it to the integer, and invoking on the hardware abstraction layer set color of the entire strip with the provided color. And the hardware abstraction layer is also provided during the initialization of the set color class. And in the hardware abstraction layer, we are implementing the class LED strip, which will be responsible for creating the pixel LED strip handle and just setting the color of the entire strip by going through all the pixels and setting each particular pixel into our color. Additionally, I have created the logger utility, which can be used across all the classes in our application. We've got also the arguments parser, so that in the main function we are able to parse the gRPC ports on which our service will be listening. So as you can see here, we are following this single responsibility principle, as well as the dependency inversion principle, because each and every layer is dependent only on the interface rather than the particular implementations. And I guess we are also compliant with the interface segregation principle, because we have many small interfaces in our application. Okay, so let's start our server on the left side. So we have here beautiful prints from our logger. So we started, initialized, let's control the services, initialized, and it is listening on the port 552. And on the right side, let's try to invoke some client which will change the color of our LEDs. Okay, so as you can see, the color is changing from magenta, cyan, yellow, So if you would like also to play with it, I will give you a link in the description to my GitHub repo, so you can clone the repository and deploy it on your own Raspberry Pi. Peace.
Okay, let's go.